I'm Chris Welch, lead consultant of design automation at Oricon in our digital enablement team, which is our global, computational design hub.
Kia ora, I'm Aleisha. I'm a computational designer from Wellington, New Zealand. I work in a central team project services hub, which means I get to work across multiple service groups from transport geotech to integrated design.
So what we're going to cover today is a bit about Oricon, previous work that we've done in computational design, the beginnings of our experiments with Speckle. We're going to talk about applying Speckle onto a project, the background of that project, some of the challenges and lessons learned on that, and then taking those lessons and applying that to Speckle at scale across the business and applying that to major projects. So just a little bit about Oricon. So we're a multinational, multidisciplinary engineering consultancy that 6,500 employees, 11 locations, and a broad set of expertises across a range of markets, everything from built environment through to rail and mass transit. Within that structure, we've also got a bunch of defined digital roles, visualization, digital solution development and programming, information management, and computational design, which Aleisha and I both sit in. So in terms of our, computational design community of practice, we've got about 250 plus folks, and that sort of is built around 25 full-time computational designers across the business, and we take that seriously. So there is a formal career path that takes you from a consultant of computational design through to a lead computational design consultant, and at which point you sort of branch off into more formal leadership paths. So there's a formal computational design culture within the business that at this stage is quite mature. We internally stylize computational design as code, so we're probably going to use those terms interchangeably just to head off any confusion. So when we talk about computational design at Oricon, in this context, we're going to be focusing on transport and mass infrastructure, because that's where Aleisha and I are both putting a decent chunk of our time. Here's an example of computational design applied to in a BIM context, where a Revit model has been 100% procedurally generated. This is one of our senior computational designers over in Melbourne. And then on the other side of things, there's obviously much more complex and detailed geometric manipulation, the building of custom workflows for connecting, for like lofting and sweeping and getting a really, really detailed geometry. So that's sort of the other side when we're not sort of focused on BIM. And then there's Speckle. So when I first joined the business, this was probably 2017, the key technology we were interested in at the time was VR, AR, and so Speckle sort of became part of that process. So you can see here on the left an augmented reality system of people making changes to a sandbox, and then that being sent in a Speckle stream to an Unreal Engine terrain, where that is then being updated in real time. And on the right, you can see a situation we had where we were sending road alignments into the HoloLens, into VR, and onto a desktop to sort of demonstrate people this real-time connection with visualization. So that's where we started with Speckle. So we had a server set up on-prem that was sort of doing all of these experiments. That wasn't the key focus of what we were trying to do as a business. The key area of upskilling of information management that we were trying to do across our cohort was in GitLab, was about managing code, getting people used to the language of branching, merging, pushing, pulling, building consistency in the way that we delivered code to the business. So while we did have Speckle, it wasn't like we weren't identifying geometric storage and geometric control as the key thing that was going to upskill our people. We saw that as a programming thing. So that's sort of why Speckle sat on the back burner as an experimental component of our workflows. And that takes us to 2022 and the work that Aleisha has been doing. So Aleisha, take it away.
Yes, so I'm going to be talking about one of the first big planes we landed. I'm going to share my experience doing code on the project I've been working on for the last year, Papakura-Jury. Papakura-Jury is an infrastructure project located in Auckland, New Zealand's largest city. The project aims to improve the capacity and functionality in the short term and provide long-term growth in the south of Auckland. It includes provision and additional traffic lane in each direction, interchange improvements, dedicated walking and cycling shared use paths, and upgrades to local road connections. The project is part of the New Zealand Upgrade Program is being led by Wakatahi New Zealand Transport Agency. The Papakura Jury project will benefit communities in the area by enhancing access to employment, schools, and leisure activities and enabling smoother flow of traffic. There's a great culture on this project of pushing for continuous improvements, including digital delivery methods, which is where I come in. Myself and Louise, another computational designer, worked together to create a workflow where we could help the geotechnical engineering team to speed up the retaining wall design process between engineering and drafting and enable them to visualize the 3D impacts of retaining walls. What we achieved was an auditable computational design workflow that can be reused, better understanding of 3D outcomes and impacts of retaining walls, a generally happy project team, and a workflow that can quickly adapt to major design changes. This stage of the project, 1B1, was looking at a large volume of geotechnical work. In New Zealand, geotechnical engineering is full of complexities due to seismic activity, weak or variable ground conditions, and environmental considerations, among other things. Geotechnical work has also had large impacts on the visuals of the project. Due to this, it is not uncommon for designs to be changed considerably, leading to rework. In previous stages of the project, geotechnical deliverables were done in collaboration between engineers and drafting teams entirely in 2D. Walls in stage 1B2 were going to be more complex and risky, so we thought that this would be an ideal place to work towards improving that workflow using computational design. We started at 50% design, developing a workflow to generate plans from a simplified 3D model. We would generate the 3D shapes in Rhino, create the plan geometry using Rhino, and save that as a GWG, which we'd then import to Civil 3D. Easy, one output per wall, one Grasshopper script for all of the walls. It was important for us to perform the movement between software because Grasshopper was the best place to set up computational design workflows, and Civil 3D produced the best documentation of the design, and this is where our drafting team works. The project's common data environment is ProjectWise. ProjectWise is a Bentley Systems product which provides a central location to store and organize the project, construction, and asset information with integration with most major design software. Unfortunately, this excludes Rhino. So in the middle of our workflow, we needed to export from Rhino and import geometry into Civil 3D out of SharePoint rather than through ProjectWise. From the foundation of this 50% design workflow, we began to build a more complicated but more robust workflow able to handle the complexities and detailed design stages. We found two main challenges. Firstly, we needed to consider that the designs will change and that the level of detail would increase, requiring additional workflow complexity. At the beginning, we were generating geometry that was not too complex and only passing minimal geometry through multiple pieces of software. As the geometry and outputs became more complex, our method of exporting out of Rhino and importing manually into Civil 3D became less feasible and harder to manage. We wanted to be able to turn around major design changes in a matter of hours. Each of the 12 retaining walls became more and more complex, and often decisions were made that were bespoke to each wall. This meant I had to move away from using one Grasshopper script for everything and build one per wall. We also needed to figure out how we would store and access geometry and metadata in a way that enables computational design workflows, while also retaining a file structure that makes sense and meets IAM standards and can cope with the number of files and deliverables that we would need. Because each wall would go through many design changes, we needed a robust versioning system at the core, and we needed to be able to quickly revert changes if a decision was reversed. Throughout the project, we were challenged on how our workflows fit into ISO 19650 standards, which we were always able to answer, but this was something we knew we needed to develop a strategy for. These two challenges were major influencing factors in our decision to move away from SharePoint and consider a different way of working. As soon as the outputs became more complicated and it became more difficult to ensure the latest geometry out of Rhino was what was being imported into Civil 3D, especially when we were working with tight deadlines. ProjectWise is great at versioning, but because we would need to be manually exporting and naming files and dragging them into ProjectWise as new versions of files, there was a lot that could go wrong through human error. One wrong number and you've versioned on top of the wrong file. As Chris mentioned earlier, we didn't have any guidance for code file management other than GitLab. So what do we do with our geometry? So we went with Speckle. Working with Speckle as a geometry repository is straightforward, but structuring it in a way that makes sense for the project was a challenge. We were not storing complete drawings or files, but components of them in a way that suited our code workflows. I found it useful to think about the geometry as a hierarchy with asset geometry as individual components I'd be working with, which are linked to an asset, which is part of a design package. This helped to logically structure my Speckle streams. I also wanted to make sure each commit contained a minimum of date and time and a name relating to the overall hierarchy so that if the commit somehow got lost, it could be traced back. This would also help with making sure we could recreate the design from a certain point in time if we needed to check or order anything. Throughout the project, I tested 3 strategies for structuring my streams and branches. Strategy number 1, I just made one stream for the whole project and had a sub-branch per package. This was overall a bit too chaotic, and due to each package or stream containing multiple assets, which each contained 3+ geometry branches, the UI made it difficult to find things. As you can see, everything past the first branch gets flattened. I found that there are a few instances where I had renamed the geometry but forgotten to rename the stream when I was reusing a computational design workflow. This would have been easy to fix by making the name it sends to the stream it sends to rely on the name but I was inputting, but I think it highlights a larger problem. Strategy 2, I went with one package per stream. This was much easier to visually follow, but there were still just as many branches. Here I had the same issue of manually needing to make sure I was sending to the correct stream. Strategy 3, I really simplified the stream and branch structure so that I didn't have to worry about sending to the wrong branch, since all I needed to do was name the geometry. Here each branch is a geometry type rather than a type specific to an asset. This produced more issues than it solved, as I had to manually choose which commit to pull down rather than just pulling the latest. But we delivered the packages, people were mostly happy, and it was a really good way to show off the potentials of computational design on a major project and develop some useful relationships with the project team. Looking ahead, there were some questions that needed more robust answers if we wanted to roll this way of working out to future projects. People were happy with the geometry, but we needed to answer questions related to the prickly stuff, like who has access to what and when, and whether Speckle works as a work in progress space or as a shared space. And that's where Chris comes in.
Thank you, Aleisha. So yeah, in terms of, I guess, on our side, the sort of global design automation context, so where we were in the My Little Hub team is that we'd successfully rolled out a tranche of internal products, which you can see on the left here, just really targeted products of all, delivering targeted upgrades to our processes internally. So the question was, now what? On the other side of things, our computational design consultants are now like deeply integrated in delivery at this point, and asking these really complex questions about information management, about controls, and wanting to do more and more, powerful stuff effectively. So our immediate focus then shifts from these sort of external products or targeted products to internal continuous improvement, which is where we are today. And part of that included a Speckle enterprise rollout. So this time around, we had Speckle in the past, obviously, as a sitting on a server, something that we were testing. So in this case here, we wanted to say no shortcuts this time, no skunk works, no sort of segmented off whatever thing. It is a fully procured and maintained, by IT processes. It should survive any churn in the team. Something that is like then built into our future budget concerns and things like that. We did a full security review. We've got production and test environments all set up. We also knew that this was something that we would need to have access to everyone in Oricon plus sub-consultants, but we knew that joint ventures would be able to scope. We wanted to keep it, as the I guess like the smaller one-off projects, that are entirely within the business. And obviously, there's an acknowledgement people are using this thing, and they're using it every day. We need to make sure that continues while we're doing this process. So the pilot rollout happened this February to a small group of people who were then given access to the various plugins on a case-by-case basis. The enterprise rollout happened in April. By May, we had a steering group set up who would then meet every month to ensure that the rollout was happening successfully. In June, we had our first automation plan approved, which I'll talk about later, which was applied to a project. August, we managed to get our second plugin tranche of like a whole range of different products at 14.4 rolled out, and then in September we started to put that together as a testing and deployment plan, which sort of takes us to now, where we're sort of in that phase here. So in terms of what worked, we ended up actually procuring this through the Speckle team, because what they were offering was actually quite competitive. So that was really good. Auth0, which is our middleware for managing access, is very flexible, and so any features that Speckle does not have in terms of level of control that they need, we can get through Auth0. And in terms of the benefits to the team, it just immediately improved data management, immediately helped answer questions about where is things being stored, is it safe, who's got access, that kind of thing there. In terms of what is still a headache today, there's lots of complex plugins, and so getting to the bottom of those issues has been quite difficult to navigate. So we're getting a better system in place for that now. And I've got here just a quote from one of our senior computational designers, actually the same one who worked on that tunnel I demonstrated at the start of this talk, saying that their script for managing movement between Rhino and Revit went from 885 components down to 16, and can be used by someone in the broader network rather than a specific code personnel. So that's a huge win on that front. So in terms of the system that we've got in place now that we're starting to roll out, we have really tried to minimize the surface area of who is having to work with Speckle deployment. We're not using the manager, we're rolling it through our normal IT processes, again, so that it can survive any churn and there's no like cordoned off knowledge. And so we have a formal testing VM that we then use to test every package as it comes through. We have our smoke testing processes so that we can confirm with IT that something is ready for deployment, and then user acceptance testing is more about, it doesn't end user have the experience that they want? Does it send them somewhere they're not expecting? That kind of thing. So we've got this really refined at this point. So, okay, we've got Speckle, we've rolled it out in the business. So the question now is, how do we use it? So at the sort of same time, I was part of a major project mobilization. I can't talk about the specifics of it, but it was an alliance structure following the ISO 19650 standard, which I won't go into too much detail, because if you need to know about it, you probably already know about it. But the key component here is that the work packages are split up into task teams, and task teams are not allowed to share work across task teams. It needs to go into this shared pattern. And that, in the end, became sort of the bounds of computational design from my perspective, which is we are not reviewing and approving anything that is going through engineering teams. It's going through layers and layers of approval before anything gets shared, and therefore all computational design just needs to exist in these WIP spaces, and then we just need to have mechanisms to take shared information and bring it back into WIP. So in regards to how Speckle works, we wanted to make sure that there was effectively two things happening. There's a shared stream, and then there's a task team WIP space that is read-write. So what that's acknowledging is, what are we actually doing when we bring an object into Speckle? We are trying to take something that's baked into a file on a disk somewhere, and we're trying to turn that into a database that can be consumed by a range of products. So that is still a read-only process. It's just really about disaggregating that data into something that is usable. So we sort of had this very simple structure that required a little bit of duplication of information and careful management of teams. In terms of naming and structure, we have kept it fairly simple, which is every project is named as project number and reference to indicate this is reference only, it's read only. And for each of those task teams, there's a single stream for all the task team data, and then if there's larger tasks like the ones that Aleisha has been demonstrating, that gets broken off as its own subtask stream. And that's all we've really needed to break things down. Again, we're not building custom functionality at this point because we don't want to have to support it. We are using what is provided by Speckle out of the box. And so here's just a couple of examples here. So when you've got a shared file and you're breaking it down to pull particular elements out, or there's a new revision of it, we want to make sure that is 100% in the stream name. It's the only way I can think of doing it to make sure that it's very, very clear. This is a read-only dissection of an existing file. And then in regards to task teams, it's just about following project standards. In this case here, it was location discipline / task of the suffix if required. In terms of how to manage these additional, I guess, like layers of administration, at the moment, I'm just doing this through polyglot notebooks. The GraphQL query language that Speckle gives us access to, super easy. As an administrator, you get a little bit more space to test things out, and that's been working completely fine. So we haven't tried to build any technology layered on top of things now. We're just really focused on this, on getting the workflows working, that the actual technology to make the stuff easier can follow. And these polyglot notebooks are very easy to maintain. What we're focused on when it comes to information management is verifiability, reproducibility, and maintainability of our geometry. So verifiability is effectively, can we tell what's different? Can a reviewer check that can a reviewer check you're working easily? Reproducibility, I think, is one key question, which is, if you wanted to reproduce a deliverable in 5 years from now, could you? I would say for a lot of places, the answer would be no. And for a lot of individuals, the answer would be no, because these things tend to have roots deep everywhere. In terms of maintainability, it's a question of, can people go on holiday? Is the same person being locked down to a particular task of reproducing the same script again and again and again, working on the same data? So these are our key focuses. And we've ended up with this pattern here, which I'll go through. I'll actually go through in reverse. I'll go from the artifact. So the artifact being what is delivered through the verification process into shared. How do we confirm that we can reproduce this artifact? So taking Aleisha's retaining walls as an example, Aleisha builds her retaining walls using code with geometry pulled out of Speckle. In delivering a particular artifact, she puts a tag into the GitLab, which tells us this artifact was produced on this date. If I ever need to reproduce it, I can go back to the source, I can click on the tag, regenerate the code, and we don't use links to branches or streams or whatever. It's always permalinks to particular commits. So the geometry can be pulled in exactly as it was into a code base, exactly as it was. And we then use the Revit or Civil 3D or Rhino kernel to regenerate the artifact. So that sort of closes the loop there and sort of covers everything that we need to cover. And then obviously we still have a very strong reliance on good standards and good readmes. But here's an example of that in Fork, which is the Git front end that we use. There's an artifact here, and if I click on it, I should be able to regenerate it completely as long as my computer is set up with the same standards. So in terms of what has worked, well, we now have standards and they've been applied on a project. We've got something that we can point to, something we can iterate on in a continuous improvement manner. We're not starting from scratch every time. This already builds on a solid culture and foundation. We weren't looking at this and saying, hey, you've got to learn Git now, or you've got to use Speckle. People were familiar with Speckle, they're familiar with Git. What we're trying to do is close the loop so all of that works together in a way that makes sense. And the feedback from project managers and information managers has been really good. They've asked us hard questions. We've been able to give them complex answers, but answers that make sense and work. In terms of what still we have places to work on, and I'm sure this is consistent across the industry, it's maintaining consistent local environments, maintaining consistent plugins. It has increased the learning curve for new starters in a way that we've had to be a bit more careful about what's introduced and where. And as sort of stated before, some of these standards and processes to require manual auditing and processing. So looking ahead, there's obviously new Speckle roles and controls coming through. There's the new Speckle front end, so we're interested in that. From a project stand-up perspective, we want to make sure that we can start to set this all stuff up automatically. There's continuous integration and deployment infrastructure we could put in place to ease some of the burden of taking stuff from shared back into WIP, and working with the visualization team to actually make use of the data that's up in the that's up in the server, and handing over succession planning between teams, handing processes directly back over to engineers so they can run it themselves, and basically trying to make sure that using these processes, we're not locking particular individuals into particular projects, and they're actually able to move across projects and deliver a lot of benefit wherever they're needed. So how do we feel about Speckle? So I guess where I'm sort of am with that at the moment now is, back in the day when it was about streaming between two people and building connections on the ground, made a huge amount of sense to me. As we've gotten more and more controls and more structure and more consideration about the information management required for a project, it's been a learning process going through of, well, what is the place of Speckle in these projects? So I think the ISO standards have actually really helped with that. It's sort of defined this as a WIP tool. All of the use cases that we've talked about Speckle have been within this WIP space, and I'm excited about the idea of removing a reliance on desktop links to get scripts to run correctly, and I guess to have these issues of people needing Rhino stuff committed to Git, or having files that are saved to SharePoint that then need to get regenerated in scripts that really start to tie people to specific computers or specific processes. So I really think Speckle is going to help with that.
Yeah, I think it's just, I think we would want to, now that I've done it on a project kind of without any kind of rules other than just generally make sure you do it properly, I'd want to spend a bit more time setting it up in a way that works for the project and really think through what it's going to be used for in the future, so that we don't have to do all the swapping around of branch/stream organization. But yeah, I think it's removing a lot of barriers around how I can work with engineers within their software and the software I'm most comfortable in, to make sure that we can, yeah, they can use the tools they're comfortable with and that produce the best outputs, and that I can use the tools I'm most comfortable in, can produce my best outputs. And that way we can get things like Grasshopper linking in with Civil 3D Dynamo and have the engineer run that Civil 3D Dynamo and me do the Grasshopper stuff. Yeah.
Yeah. And then I guess at an organizational scale, it's been about maturing. It's been about getting the right security processes in place. It's about acknowledging the need for standards. And I think Speckle has really been a foot in the door for us to improve a lot of our other processes as well. So yeah, it's been an exciting journey. We're only just getting started, I think, with what we can do, and more people within the business are starting to take notice, which is really exciting. So thank you very much. Pleasure to be here, and look forward to any discussion in the comments, or happy to answer any questions now. Thanks very much. Hi.
Hey, Chris and Aleisha, thank you so much for your presentation. We have a few questions for you guys. Happy to read these out loud for you. Oricon works alongside Arup on multiple projects. Would they be exploring using Speckle as a collaboration tool?
So one of the projects that we've worked on with Speckle was actually with Arup. So we actually had procured the Speckle server for that alliance through Arup, and that worked really well. I think when it comes to collaboration in Speckle, the challenge I have at the moment is, well, for Australia specifically, Australia and New Zealand, well, Australia more so, is that there's the data sovereignty requirements about where data is stored, which leans to self-hosting and various other things. From the I guess perspective of smaller projects, again, I think one of the questions I have is where when it comes to permissions, when it comes to server access, what's the best way to sort of manage that? From what I've seen, the new Speckle feature for guest roles helps that, but I haven't sort of put that through its paces. So it's still requires sitting down, having an automation lead of some kind on the project, sitting down and processing through the information management side of things. But yeah, no, it's good. It's a really like power positive thing.
Great. And then the final question: do you see Speckle replacing any other tools than ProjectWise in the future?
So I think I can't remember which one of the first speakers said it, but I think that one of the powers of Speckle is the fact that it can, in theory, substitute anything. So being able to open up an Excel, a schedule in Excel, make some modifications and send it back up. The benefit there is that it's not a direct one-to-one connection. You could interrupt that at any point, replace it with some kind of web service or anything else. So I think the cheeky answer is anything. When it comes to sort of file management and permissions and flows like that, I'm not 100% sure Speckle is super interested in playing in that space, but potentially. I think the workflows are well known. Like what is required to fulfill 19650 is pretty clear. It's just a case of getting everyone to play ball, and that will just take time, I think.
Right. Well, thank you so much again. We know it's pretty late for you guys, so it was great to have you on stage with us today, and have a great night.
Pleasure to be here.
Thank you.
I will say one thing, which is we are recruiting, and I'm going to put a link in the chat. That's the end.
Nice. All right. See you. Bye.
Cheers.